Okay, what's in this section is basically a synopsis of the different types of reactions. You need to be able to look at a reaction and classify it into one of these groups, and you need to be able to draw a chemical equation, balance it, and determine which type of reaction it is. Finally, this ends up with you being able to predict the products of a reaction based on the reactants. So again, this is one of these sections that's based on the 2 or 3 chapters before. If you can't draw a chemical formula, write a chemical formula, or give a name, then you know what, you're going to find this challenging. So I'm encouraging you to talk to me, get some help, whatever you need to do to make sure you master this stuff. And probably for some of you, it's the building blocks leading up to this. So let's move on. I realize that you can read, but sometimes it helps to actually hear it as well. So one of the reaction types is simply combustion, burning. A combustion reaction is when all substances in a compound are combined with oxygen. So immediately what I see in my mind is something reacting with O2. Oxygen is diatomic. Somewhere in the preceding chapters, you were blessed with a list of all the diatomic molecules. Make sure in these formulas you're not ever writing just H, because hydrogen exists as a diatomic molecule, H2, same thing with oxygen, fluorine, iodine. See the list. Anyhow, the point is here, combustion, if you see something combining with oxygen, chances are you should go down the combustion route and just check it. The products of a combustion reaction are going to be CO2, carbon dioxide, and water. It's commonly called, as I said, burning. It's an exothermic reaction, which means heat is produced and is easily recognized or distinguished. If you're holding a test tube, you're going to notice it's getting warmer. If you have a thermometer in there, you're going to notice an actual temperature increase. So an example of a combustion reaction would be when you take a hydrocarbon. In this case, you recognize it as organic, a 10-carbon molecule, and you burn it in oxygen. Nice little blue flame you're going to get, and you're going to get a whole lot of CO2 and water. And again, notice the coefficients here. I've put them in red just to distinguish them from the actual formula itself. A second type of reaction is synthesis, to build up. A synthesis reaction is when 2 or more simple compounds combine to form a more complicated one. These reactions come in the general form of A plus B, those are the reactants, produce AB. One example of a synthesis reaction is the combination of iron and sulfur to form iron 2 sulfide. So if I gave you a word equation, this is a word equation, iron plus sulfur gives iron 2 sulfide. You should be able to draw iron plus sulfur forms iron sulfide. And again, like the diatomic molecules, sulfur is octaatomic. It forms a molecule of 8 atoms. So once you get that skeleton equation down, you would then notice that it needs to be balanced. Point here is, though, that you have A plus B gives something totally different, something more synthesized, combined, a product. What if you took that product and now broke it down? So this is the third reaction type. It's called decomposition. Decomposition is the opposite of a synthesis reaction. A complex molecule breaks down to make simpler ones. These reactions again come in the general form AB, decomposes to form A plus B. Just the reverse of a synthesis reaction. So one example of a decomposition reaction is the electrolysis of water to make oxygen and hydrogen gas. You stick a wire into some water, and at the positive electrode you will get one gas, and at the negative electrode you'll get the other gas in the ratio of 2 parts hydrogen to 1 part oxygen. Bubbles, gases. And of course, this would be the word equation, this would be the formula equation, and then it has to be balanced. Single replacement reaction. This is when one element trades places with another element in a compound. The general form would be, usually, this metal replaces this metal. A replaces B, and now you have a compound AC, and what's left over is B. So a single displacement reaction is when magnesium replaces hydrogen in water to make magnesium hydroxide, a base, and gives off little bubbles of hydrogen gas. And again, word equation, now you have to write the formula equation and balance it. Magnesium plus water gives magnesium hydroxide plus hydrogen gas. Notice again, it's diatomic. And again, recognize that this is single replacement because magnesium, that's A, reacts with a 2-element compound, BC. B is hydrogen, C is oxygen. A combines with C, magnesium hydroxide, and you are left with hydrogen. It's also, of course, combined with some hydrogen as well, but we're not going to worry about that. Double replacement. Now this gets a little more complicated. This is when the anions, negative ion, and cations, the positive ion, of two different molecules switch places, forming two entirely different compounds. These reactions are in the general form AB plus CD. Notice the A goes with the D and the B with the C. Metals always go first, non-metals second, regardless of where you are in the equation. A double replacement reaction would be a reaction of lead 2 nitrate with potassium iodide to form lead 2 iodide and potassium nitrate. And again, you can see if you are stumped by 2 chapters ago writing formulas, that's going to cause you a little bit of stress. So it shouldn't cause you stress. Why not just learn how to do it, right? So lead 2 nitrate is PbNO3 plus potassium iodide. Notice that's the AB. CD is potassium iodide. We want A with D, so the metal is going to go with iodine, lead iodide, and potassium nitrate. Double replacement. No sweat. Finally, there is a reaction type simply called an acid-base neutralization. If you add an acid to a base, you're going to get salt and water. So this is a special kind of double displacement reaction that takes place when an acid and base react with each other. The hydrogen ion in the acid reacts with the hydroxide ion in the base, causing the formation of water. Generally, the product of this reaction is some ionic salt and water. So if I have an acid, and again, most acids are hydrogen first and then a nonmetal, plus a base, bases have hydroxide, you're going to form water and a salt. So a typical example would be the reaction of hydrobromic acid, HBr, with sodium hydroxide to form the salt sodium bromide and water. One more page. Most of these chemical reactions involve energy. Make sure you're clear on the difference between some of these types of energy reactions. Chemical reactions will either involve the production of energy or they require energy or to absorb it. Reactions that give off energy are known as exothermic reactions. Reactions that use up or need energy are known as endothermic, To show that a particular reaction is either exothermic or endothermic, we would include the term energy in the equation. For example, methane is burned in oxygen to form carbon dioxide and water. Do you recognize what kind of reaction that is? Of all the reaction types you've looked at, you should say, ha, that is combustion. This is reacting with oxygen to form carbon dioxide and water. What we're getting at here is, though, that reaction releases a whole lot of energy. It is, therefore, exothermic. You are not going to feel comfortable with these unless you look at a whole lot of examples. So again, there's some wonderful videos on the website, PowerPoints, resources like you can't believe. So go through a few of them until you really feel convinced, and then move on to one of the alternative labs for this section or to some of the computer stuff. And of course, there is always more than computer stuff. There's always going to be a little bit of paper. This is like balancing chemical equations. You need to have practice with it, right? So, yeah, a big part of this section is just being able to, over and over again, recognize what type of chemical reaction it is based on what you see in that equation. So, the study guide on paper is essentially notes, and notice that they actually give you the page numbers recommended to find the answers. I don't think you'll have any problem doing this. I just wanted to quickly show you what it is you're doing here. And again, there's probably no reason you have to actually hand this in when we have our little hot seat interview. You can just show me that you've done it, right? But just for example, in a synthesis reaction, two reactants combine to form one product. They're already giving you an explanation as to just what a synthesis reaction is. So I would think for this section here, if you can just give me an example of one, I'll give you one just to be kind. Let's say we have the metal aluminum, and we react it with sulfur to form, and again, this is where you want to get really fancy. What if I didn't even tell you what the product is? You can tell this is A plus B gives AB, right? It's going to be synthesis. So aluminum plus sulfur is going to be Al2S3. And again, you can't just put ALS because you have to look at the charges of sulfur and aluminum. Sulfur is -2. You've got 3 atoms of sulfur, so the charge on sulfur is -6. That would mean the aluminum has to be +3 because you've got 2 of them. 6 plus -6 adds up to 0. So yeah, as long as you can come up with an example for each of these types of reactions, you're good to go. Next section is simply vocabulary, and here the idea is not to just copy it out of a book or even on the material above on the page, but to put it into your own words. When you have to put something into your own words, it makes your brain process it, and basically it's a synthesis process in your brain that's going on in order to end up with something we would call learning, right? So again, I don't think you'd have any problem. If I was going to do synthesis, I would say 2 single reactants come together to form a larger or joined product. Right. And then you get to draw something. So draw a diagram that illustrates what happens to the reactants and products during each type of chemical reaction. Use symbols of your choosing to represent atoms and ions. So you already have used words to process this information. Now your brain is going to be forced to actually use some sort of symbols to somehow convey just what a synthesis reaction is. I am not an artist, so guess what I'm going to do? If I'm going to draw a synthesis reaction, I'm going to say Mr. Triangle plus Mr. Square come together, and they form one of these, which I have no idea what we'd call that, but it is a synthesis of both that and that. Obviously, A plus B gives AB is also a synthesis, but you know what? We're trying to look for something a little different here. So see if you can come up with some creative way of showing visually what those reaction types would be. There's some wonderful ideas, by the way, on the video section on the website that you could check out. And finally, that last page, predicting chemical reactions, this is where the rubber hits the road. If you can do this successfully, you know 9.3 probably more than you should know about 9.3. I'm going to add one little added stipulation to this puppy, and that is that you not only predict the products, but you balance it, and then you say what kind of a reaction it is. Is it synthesis, single replacement, double replacement, etc., right? So which one shall we do for you, just to make your life simpler? This one in number 2, I'm seeing something that looks to me like, seems to be in the form A plus B gives, well, pen's not working, AB. So, nitrogen plus hydrogen together are going to form NH3. How do I know that? Just the same way I know that any time those two elements come together based on the number of valence electrons, their charge, that is the formula for ammonia, right? So A plus B gives AB. I would then have to balance it. 2 hydrogens on the reactant side, 3 on this side. What if I put a 2 in front of, whoa, that's not good, 2 in front of NH3, and I put a, see, that takes care of the hydrogen. 2 times 3 is 6, and a 3 here gives me 6 hydrogens. 2 nitrogens, 2 nitrogen. We're good as far as balance goes. The only thing we would have to do now is say this is in fact a synthesis reaction. Cool. This looks to me like you're starting off with something that's going to break down. Decomposition reaction. The only thing it can break down into would be magnesium and chlorine. And again, chlorine is diatomic, so make sure it's Cl2. Then I check 2 atoms of chlorine, 2 atoms of chlorine, 1 atom of magnesium, 1 atom of magnesium. It's balanced. What kind of a reaction is it? That puppy is decomposition. I'll let you in on a little secret. When I'm doing these, what I'm looking for, quite honestly, I will do all the combustion reactions first, because to me they're the easiest ones to recognize. You have a hydrocarbon and it's burning in oxygen. Therefore, what do you get in all combustion reactions? You get carbon dioxide and water. In other words, combustion. And right, that puppy is not balanced. I got 6 atoms of carbon here, but only 1 here. That defies nature. That's not the way God intended it, right? So I'm going to basically put a 6 there, and then I'm going to have to put a 6 here. I wish that would stop. Anybody know why that's happening to me? Tell me what that's all about. And then 6H2O. There has to be a way of resting your hand on a tablet without launching a bunch of other apps, right? So somebody educate me. So that's combustion. Yeah, we don't want to give you too much help here. If you do need help with some of these, make sure you talk to me, right? I am going to tell you number 10, though, because I don't think anybody would recognize this. If you have hydrogen peroxide and you stick it in a little beaker, what you're going to notice is little bubbles. Those bubbles are oxygen. But what you're left with is water. So you actually are decomposing hydrogen peroxide into water and oxygen gas, those little bubbles I was referring to. And of course that is not balanced. I've got 2 hydrogens here, 2 hydrogens here, that's good. 2 oxygens here, but I've got 2 plus 1, 3 on this side. I think I'm going to have to put a 2 there, and I'm going to have to put a 2 over here. Now everybody's happy. This is decomposition. Decomposition. Okay, I think you're good to go. Make sure you do the study guide or see me for an alternative to all of this good stuff.